Here we have a math problem on exponential equation. That is, we have to solve for x in the given exponential equation. That is, we have to find the value of x. Okay, now let me take the given equation as it is. That is 1 positive square root of 3 to the x power equals to 2 to the x power. Okay, here we have 1. 1 is raised to any power still equal to 1. That is 1 to the first power equals to 1, 1 to the second power equals to 1, 1 to the 50th power equals to 1, 1 to the 100th power. Whatever exponent we take for 1, it's still equal to 1. Okay, now let me take some exponent for this one, that is x. Okay, even if 1 is raised to the power of x, still it is equal to the original value 1. Okay, now let me divide both sides of this equation by 2 to the x power. That is here 2 to the x power divided by 2 to the x power. Okay, here 2 to the x power is a common denominator for 1 to the x power and square root of 3 to the x power. Since it's a common denominator, it can be taken as denominator separately for this and this. Then I'm getting 1 to the x power divided by 2 to the x power positive square root of 3 to the x power divided by 2 to the x power equals to, so here when I divide 2 to the x power by 2 to the x power, it will just become 1. Okay, here we divide two powers with the same exponent x. Whenever we divide two powers with the same exponent, what we can do is we can take the exponent in common. Then we get 1 over 2 raised to the power of x. Here we have the exponent x inside the radical. Whenever we have some exponent inside the radical, we can take the exponent for the radical. That is, we can write this stuff as square root of 3, and we can take this exponent x for this radical, that is square root of 3 raised to the power of x divided by 2 to the power of x equals to 1. Okay, 1 over 2 to the x power positive. Okay, here we divide two powers with the same exponent x. Now what we can do is we can write this exponent x in common. Then we get square root of 3 over 2 to the x power equals to 1. Actually, this 1 over 2 is the value of the trigonometric ratio sine of 30-degree angle measure. And the square root of 3 over 2 is the value of the trigonometric ratio cosine of the same angle measure 30 degrees. So instead of 1 over 2, I can write sine 30 degrees to the power of x positive. Instead of the square root of 3 over 2, I can write the equivalent stuff, that is cosine of 30 degrees to the power of x equals to 1. Okay, now we can move this exponent for this sine around. Then we get sine to the x power of 30 degrees. Positive, the same thing we can do over here. That is a cosine to the x power of 30 degrees equals to 1. Okay, now let me consider the Pythagorean identity in trigonometry. That is sine square theta positive cosine square theta equals to 1. So this identity is true for any angle measure that we have at the place of theta. But here at the place of theta over here, at the place of theta over here, we must have the same angle measure. For example, let me consider 30-degree angle measure at the place of theta. Then the identity will become sine square 30 degree positive cosine square 30 degree equals to 1. Okay, now let's compare this equation and this equation. On the right side, here we have 1 and here we have 1. On the left side, we have sine 30 degree. Here sine 30 degrees. And here we have cosine 30 degree. Here we have cosine 30 degree. So everything is same. So except the exponent. At the place of x, what do we have over here? We have 2. Therefore, the value of x is 2.